So this is another question related to topic moles. In this question, an excess, the term excess means like more than enough, like too much we are using. An excess of nickel carbonate, like we have more than enough nickel carbonate or too much nickel carbonate, which is about 12 gram, was added to 40 cm cube of 2 mole per dm cube sulfuric acid. The unreacted nickel carbonate was filtered off and the filtrate evaporated to obtain the crystals. Mass of 1 mole of nickel sulfate. The term excess means more than enough, extra. When something is in excess, in chemical reaction, it means it is extra or too much. So we have, like in the question, we have 12 gram of nickel carbonate that reacted with 40 cm cube of 2 mole per dm cube sulfuric acid. The unreacted nickel carbonate was filtered off and the filtrate was evaporated to obtain the crystals. Mass of 1 mole of nickel sulfate and nickel carbonate is given. Now the main question, we have to calculate the mass of unreacted nickel carbonate. So how to get the mass of unreacted nickel carbonate? Because this is a total nickel carbonate which we are adding. First we'll find how much nickel carbonate is reacted. So the total which we add minus the reacted will get how much is unreacted. But for this you have to follow the steps again. Calculate the number of mass of unreacted nickel carbonate. The first part, the number of moles of sulfuric acid. So first part already they did for you, that in 40 cm cube and 2 mole per dm cube they got 0.08. And how they solve this one, they use a formula to get the moles. How they use, which formula they use? Because we know moles is equals to concentration into volume. The concentration is 2 and the volume, but it is in cm cube, so you have to convert into dm cube. So divide by 1000, 40 divided by 1000, it will be 0.04. So it will be 0.04, so 2 multiplied by 0.04. That's why the answer for number of moles is 0.08. So the first one, is done with a formula. So if the first part is done with a formula, the second part will be done with the ratio. So how to get the moles of nickel carbonate, the reacted moles of nickel carbonate? Look, even though we have the mass of nickel carbonate, but we are not using a formula because this is extra. This is like too much. We don't, and they mention it is excess or extra. So this all 12 gram does not react it. That's why we are not using the formula. So we'll use a ratio. What ratio we'll take? We'll take a ratio between sulfuric acid and nickel carbonate. So what is the ratio between sulfuric acid, H2SO4, and nickel carbonate? The ratio between them is 1:1. So if the ratio is 1:1, if we have 0.08 moles of sulfuric acid, how many moles of nickel carbonate will be there? So we cross multiply, 1 will be multiplied with x, so it will be x, and 1 into 0.08. So we'll get 0.08 moles of nickel carbonate that reacted. Is it clear, the second part? Now to get the mass of nickel carbonate reacted, so again we use a formula. So to get the mass of nickel carbonate reacted, you have a formula that moles equal mass in gram divided by the molar mass. The moles of nickel carbonate are 0.08. Mass in gram is unknown. For molar mass, you have to check the periodic table because the molar mass of nickel carbonate, NiCO3, we have to check a periodic table. So nickel carbonate, NiCO3. So nickel is 59. Then carbon is 12. Then oxygen is 16 multiplied by 2. So 16 multiplied by 3. So when we add them, it will be 48 plus 1250 plus 48 plus 1260 plus 59 119 will be the total mass. So molar mass is 119. So this was 0.08, and we are using a formula to get the next part, that moles equal mass in gram divided by the molar mass. The moles were 0.08, mass in gram is unknown, and the molar mass is 119. So 119 is divided, other side it will be multiplied. So 0.08 multiplied by 119, that will be equal to 9.52 grams. So 9.52 gram is what is reacted. And the total, the total which we add, that was 12. So the excess of nickel carbonate, the amount of nickel carbonate which was used, that was 12, the total. And out of 12, only 9.52 is reacted. So the question, the next part is how much is unreacted? So if I add 12 and out of 12, 9.52 is reacted. So how much is unreacted? So it will be 12 minus 9.52. That will be 2.48 grams. So 2.48 grams will be the unreacted nickel carbonate. So this is a chemical term. When any reactant is too much or extra, we use the term excess. And when any reactant is limited, so we call that as limiting. Because in the question, nickel carbonate is extra too much, so we call excess, and sulfuric acid is reacted completely, so we call that as a limiting reagent. These are the chemical terms used for the extra reactant and the limiting reactant or limiting reagent. Is it clear, this question? Anyone having a doubt? Okay, another question, a similar question related to the moles. 9.12 gram of anhydrous iron sulfate, iron 2 sulfate. So the formula for iron 2 sulfate is FeSO4. Why? Because iron is plus 2, as they mentioned, iron 2, and sulfate is SO4 minus 2. So when we simplify the valency, so it is 1 and 1. And we cross multiply, so this 1 will be with iron and 1 with sulfate. So 1 we don't write, so it is FeSO4. That's the formula for iron 2 sulfate. It is heated. Calculate the mass of iron 3 oxide formed and the volume of sulfur trioxide. The term RTP means room temperature and pressure. The mass of 1 mole, so molar mass is given. The first one, we need the number of moles of iron sulfate. So if we need the number of moles and we have the mass of iron sulfate, what we can do? So we can use a formula here. The formula to get the moles from the mass, that is moles equal mass in gram divided by the molar mass. So the mass in gram for iron 2 sulfate, that is 12. And what about the molar mass? You don't have to find the molar mass. They provide the molar mass for iron sulfate. It is 152. So it will be 12 divided by 152, which is equals to 0.06 moles. Is it clear, the first part? Not 12, 9.12. By mistake, actually I circled this, so I read this 12. That's why I mentioned 12, but it's not 12, it is 9.12. Is it clear, the first part? It's not 12, it is 9.12. By mistake, I read this only and I mentioned 12. Now, number of moles of iron 3 oxide. Nothing is given about iron 3 oxide. So what we will use? So we'll use a ratio. So what ratio we'll use? We'll take a ratio of iron sulfate and iron 3 oxide. When we check the equation, the ratio from equation is 2:1. So if you have 0.06 moles, then this will be X. Now cross multiply. So this 2x is equals to 0.06. X is equals to 0.06 divided by 2. That is equals to 0.03. Is it clear, the second part? Then the third part, mass of 1 mole. The mass of 1 mole means molar mass. Yes, Hiba, you have any question? So mass of 1 mole refers to molar mass. And how we get the molar mass? Molar mass is always by using a periodic table. Molar mass is from periodic table. So we use a periodic table to get the mass or the molar mass. This is the extra thing they added here. Some of the questions they do not include this part and you have to directly get the moles. But here they added this part that you have to find the molar mass. So how to get the molar mass of iron 3 oxide? So we will check the periodic table. The molar mass or mass of 1 mole. So what we have to do, we have to use a periodic table. So for iron 3 oxide, Fe2O3, Fe2O3, iron is 56 times 2 plus oxygen is 16 times 3. So that is 112 and that was 48. So we already did in the previous part, that was 160. So the molar mass or mass of 1 mole will be 160. This was 0.03 and this was 0.06. So we use formula ratio. Then this part we use a periodic table. So what we should use to get the mass of iron 3 oxide? So we should use a formula. And formula state that moles equal mass in gram divided by the molar mass. Moles are 0.03, mass in gram is unknown, and the molar mass of iron 3 oxide, that is 160. So 160 multiplied by 0.03, so it will be 4.8 grams. Is it clear? Then for sulfur trioxide, they're asking the moles of sulfur trioxide. Nothing is given about sulfur trioxide. So if nothing is given about sulfur trioxide, then it will be a ratio. So we can take any ratio because we have moles of iron sulfate, we have moles of iron oxide. So we can take any ratio, we'll get the same answer. So if I take a ratio between iron sulfate and sulfur trioxide, 2:1 is the ratio. So if we have 0.06, then this will be x, then cross multiply. This will be 2x is equals to 0.06. So x is equals to 0.03. We'll get 0.03 moles of iron, moles of sulfur trioxide. Then we need the volume of sulfur trioxide. So what we should use to get the volume now? So we'll use the formula, and the formula which relate the moles with volume, that moles of a gas is volume of a gas divided by 24. So moles equal volume. So moles are 0.03, volume is unknown, of gas, divided by 24. 24 is divided, other side it will be multiplied. So it will be 0.72 decimeter cube. So you can see again a trend, the pattern in the question. First one was done with the formula, then ratio, then again formula, then ratio, and then again formula. Only this part, because it was using a periodic table, so we did not use any formula or ratio. So there is a pattern in these moles question. A sequence is there, and the parts are interrelated. What you did in the first part, you have to use that to answer the second part. Is it clear, this question? Anyone having a doubt? Abdullah Khan, Heather, Isra. Another question related to the moles. In this question, calcium chloride is made by reacting calcium carbonate with hydrochloric acid. You can see the equation is given. An excess means like extra amount or greater amount of calcium carbonate was added to 50 cm cube of 0.5 mole per dm cube hydrochloric acid. The solution was filtered to remove excess of calcium carbonate. How many moles of HCl used in the experiment? So I have the volume and I have the concentration. So what I should use to get the moles? How to solve the first part? Ratio or formula? So we'll use a formula, but which formula we will use to get the moles? which formula we will use to get the moles? The second formula, which is concentration multiplied by volume. Concentration is 0.5. The second is the concentration into volume. The third is volume divided by 24. That is only valid for gases. For solution, it is concentration into volume. But the volume here is given 50 cm cube. The volume here is 50 cm cube. So we have to convert into dm cube. How I convert cm cube into dm cube? So we'll divide by 1000. So 0.5 divided by 1000. What I will get? 50 divided by 1000, that is 0.05. So this is 0.05 is the volume and concentration is 0.5. So when you multiply these two, your answer will be 0.025. So first we use a formula to get the answer. Number of moles of carbon dioxide. Anything is given related to carbon dioxide? So nothing is given related to carbon dioxide. So then how to do this? We'll get the ratio. So what ratio we will take? We'll take a ratio because HCl moles are there. So we'll take a ratio between HCl and carbon dioxide. So what is the simplest ratio? For HCl it is 2 and carbon dioxide it is 1. 2 is to 1. So if we have 0.025, then how many moles of carbon dioxide? X. Cross multiply. 2 will be multiplied with X. So it will be 2x is equals to 0.025. 2 is multiplied, other side it will divide. So 0.025 divided by 2. So 0.025 divided by 2 will get 0.0125 the moles of carbon dioxide. Then we need the mass of carbon dioxide. How to get the mass of carbon dioxide? We'll use a formula. What formula we'll use? Moles equal mass in gram divided by the molar mass. So we have the moles already, which is 0.0125. Mass in gram is unknown. And the molar mass of carbon dioxide, because carbon dioxide is CO2. So molar mass of carbon dioxide, when you check the periodic table, carbon is 12 and oxygen is 16. So it will be 16 multiplied by 2. So 12 plus 16 multiplied by 2. So 12 plus 32, that makes 44. So molar mass is 44. So if 44 is divided, other side it will be multiplied. So 0.0125 multiplied by 44. How much mass of carbon dioxide is there? 0.55 grams. 0.0125 multiplied by 44. So that is 0.55 grams. Is it clear? Then we need the volume, because if we need a volume, again we use a formula for the last part. As we need the volume only, so again we are using a formula that moles equal volume of a gas divided by 24. So moles, we have the moles 0.0125. Volume is unknown for a gas and divide by 24. This 24 will be multiplied. So we'll get the volume of carbon dioxide, which is 0.3 decimeter cube. So this is 0.3 dm cube as the answer. So this is how we solve this question. The reason why we did not use a ratio for the last part, because we already have the mole, so we just use the formula to get the volume of gas. Is it clear, this part? So moles question, if you check, the weightage is more, but these questions are very easy. Only what it need practice. Like if you practice more questions, the pattern of the question is same. So you can see 2 plus 1 3 plus 2 5, and at the last 6 marks are there for this simple question. That is a greater weightage compared to the other questions. Okay, another question. We have to calculate the number of, in this question, a dilute sulfuric acid reacted with sodium hydrogen carbonate in a neutralization. Neutralization in the reaction in which acid and alkali react with each other. In titration, 0.2 mole per dm cube of sodium hydrogen carbonate. Sodium hydrogen carbonate means NaHCO3. Is used to neutralize 20 cm cube of concentration 0.15 mole per dm cube sulfuric acid. So we have the volume of sulfuric acid, we have the concentration. Number of moles of sulfuric acid. How to get the moles of sulfuric acid? So what I should use to solve the first part? Formula or ratio? So we'll use a formula, and the formula is the moles equal concentration into volume. The concentration of sulfuric acid is 0.15, and the volume is 20 cm cube, but it should be in dm cube. So when I divide by 1000, it will be 0.02. So 0.15 multiplied by 0.02, that will give us 0.003 moles. 0.15 multiplied by 0.02. So this will give you the moles of sulfuric acid. Then calculate the number of moles of sodium hydrogen carbonate. For sodium hydrogen carbonate, we have the concentration, but we don't have the volume. So we have concentration, but we don't have volume, so we cannot use a formula. So if we cannot use a formula, then what we'll use a ratio. Because the information is incomplete, we have concentration of sodium hydrogen carbonate, but we don't have volume. So calculate the number of moles of sodium hydrogen carbonate. So what is the ratio between sulfuric acid and sodium hydrogen carbonate? That if you have 1 mole of sulfuric acid, there will be 2 moles of sodium hydrogen carbonate. So the ratio between them is 1:2. So in the question we have 0.03, 0.003. Then how many moles should be there? X. We cross multiply. 1 is multiplied with X, and 0.003 multiplied with 2. So we'll get as 0.006 moles of sodium hydrogen carbonate. Then to get the volume, but this is a volume of solution. Like what some student think, if it is written volume, they use the formula moles equal volume divided by 24. That's wrong here. Why it is wrong? Because they mention it is aqueous, so it is a solution. For solution, this formula is not valid. It is only valid for gases. So if you have a solution, then you have to use a formula for solution which relate the concentration and volume, that moles equal concentration multiplied by volume. Now to get the volume here, we have the moles of sodium hydrogen carbonate, which is 0.06. The concentration is given 0.2 and the volume is unknown. If 0.2 is multiplied other side, it will be divided. So 0.006 divided by 0.2, what is the answer? 0.006 divided by 0.2, what is the answer? The answer will be in dm cube. So answer is 0.006 divided by 0.2. The answer is 0.03. So when we solve this, it will be 0.3, but that is in dm cube. If you check the question, they are asking in cm cube. So we have to convert the dm cube into cm cube. So we have to multiply by 1000. So 0.3 multiplied by 1000. So it will be, sorry, this is 0.03. So 0.03 multiplied by 1000, it will be 30 cm cube. Is it clear, this question? Anyone having a doubt? Yeah, what about others? So first we use a formula, then we use a ratio, and then again we use a formula. But the important thing, you should remember one fact, that what some of the student did, they simply use a formula that moles equal volume divided by 24. And they multiply mole with 24 and they wrote the answer. But that's wrong. Why it is wrong? Because that is only valid for gas. If there's a gas, then you can use the formula. If it is a solution, then it is concentration into volume. So these are the moles questions. So we are done with topic 4, which is about stoichiometry. In this topic, we discuss first the empirical formula, then we discuss the molecular formula, and then we discuss how to solve questions related to moles by using formula as well as ratio. Any question related to this topic or the class today? So first was empirical formula and the second one is the moles concept.